Hi dear students, welcome back to my sessions. In our last session, we discussed source conversion techniques, which comes under the chapter number 2, and chapter number 2 name is DC theorems, DC network theorems. Under the theorems, we discussed the first topic, that is source conversions. On the conversions, we converted before the conversion, we discussed the um, ideal voltage sources and ideal current sources, and also we discussed the VI characteristics of ideal voltage sources, ideal current sources, and also we did the conversion of the non-ideal voltage source to the non-ideal current source, or practical voltage source to the practical current source. Also we discussed the non-ideal current source to the non-ideal practical non-ideal voltage source, and we solved a few problems on the basis of conversions, vice versa, of voltage source to current source, and that is set on our previous session. Now in this session we are going to discuss main topic, that is the DC network theorems. On these theorems, first we will see the superposition theorem. This theorem is one of the most important theorem in chapter number 2. Actually, what theorem statement? First, the very important of any theorem is the statement is very important. Already you know what is important of statement. Here also same importance here. Let me read this statement. In a linear bilateral resistive network containing two or more voltage sources, means wherever the linear and already you know what is the definition of linear and bilateral. What is the definition of linear and bilateral? You should remember. If you have any doubts on the linear bilateral, please go to my previous sessions, then just watch that session, then you can able to learn those concepts. But as of now, I am not going to be discuss those linear and bilateral again. So in a linear bilateral resistive network containing two or more voltage sources, the resultant current in any branch in algebraic sum of the currents that would be produced by each voltage source acting alone, and all other voltage sources are being replaced by their internal resistance. This is very important. So here, before discussing this statement, whatever I stated just now, let me read these points on the screen. The superposition theorem extends the use of Ohm's law to circuits with multiple sources. So wherever the multiple sources are there, you can use this. Let me add my pointer. Wherever the multiple sources means multiple voltage sources or multiple current sources or mixed multiple sources, means voltage and current sources, like that. So wherever the multiple sources, we can use this superposition theorem. And what is the definition, actual definition as per this slide? The current through or voltage source an element in a bilinear bilateral network equal to the algebraic sum of the currents or voltages produced by the independently by each source. That was superposition theorems. Means if any circuit have the two or more than the two voltage source or current source, so for the checking of this superposition theorem, you should make active only one voltage source at a one time. After that, you should make that voltage source by short circuiting or open circuit based on their internal resistance, based on the property as per the ideal voltage source or ideal current source. Then you should apply the superposition technique theorem like this. So the superposition theorem is very helpful for determining the voltage source voltage across an element or current through a branch when a circuit containing multiple number of voltage or current sources. So this technique is using for only based on the for the finding of particular branch current, right? So you can use for so you should remember, for superposition theorem you should make active only one source, other sources is going to be replaced with their internal resistance. That what I stated in before this theorem. So I will repeat it, the statement, my statement, that is the definition. So the actual statement of superposition theorem is, in a linear bilateral resistive network containing two or more voltage sources, the resultant current in any branch is the algebraic sum of the currents that would be produced by the each voltage source acting alone, and all other voltage sources are being replaced by their internal resistance. Either may be voltage sources or either may be current sources. Instead of voltage sources, you can use voltage sources are current sources. That is not for the use for the voltage source. You can use mixed sources, right? This is about the first slide. And here there are certain conditions are there before we are applying for the superposition theorem to the network. So there are certain conditions. First, what is the condition? In the definition, we discussed linear and bilateral, right? These two terms we mentioned. We mentioned linear, that the network should be linear and bilateral. What is the meaning of linear? The characteristics who may be V and I should be linear means the properties of current should not be vary with respect to voltage, and current should not be vary with respect to their internal properties. That is a linear, means like this property means they are completely constant, means V proportional to I is called linear. What is the meaning of non-linear? Non-linear means they have some saturation characteristics like this. This is not linear, right? So like this is comes under the linear. Linear means you can take it an example of R, L, C. Those properties are means passive elements are linear elements. What about the non-linear? Is the diode is a non-linear element. Already you know how the diode symbol is like this. So this is non-linear symbol. That is a linear symbol, right? Next, all components must be linear. So that is the first rule. All component must be linear. For example, the current is proportional to the applied voltage. For resistors, flux linkage is proportional to the current or in inductors. So this is the linear, already you know, for resistors, inductors, and the capacitors. V is proportional to C, right? Charge is proportional to V. Same etc. means some capacitor term is comes to the picture here. What I am stating is all components must be linear. What is the meaning of linear? Here the current, let me add that point clearly. Here that current is proportional to voltage, means I is proportional to voltage. After this conversion, you will get a constant of, by conversion of that proportional to, that will get constant of I is equals to V by R, means R is constant, you will get. Same thing, flux linkages means psi is proportional to I. From this, after derivating of this flux linkage and constant, flux linkage is nothing but a n number of turns, and flux linkage is nothing but number of turns and flux, means n proportion n phi, and it will become is equals to the proportional to will become constant is equals to L. Then by doing this flux linkage sign, you will get a constant of L. Then what about this etc means you will come, you can include as a capacitor term. How you can include? Let me remove this. Here we can't explain all the wording. That is the reason I added the etc. So for anyway, I'm going to explain what is the meaning of further about the capacitor, why I included the capacitor term. Let me add that. So here the what is the capacitor? Q proportional to V, means charge proportional to V. Here the charge is proportional to voltage, is you will get a constant of capacitor. Like this, all are proportional to. If you observe this, I and V proportional, flux linkages and current is proportional, charge and V is proportional, like this. So this comes under the category of linear. That is the reason I said R, L, C are linear elements, linear passive elements. So that about the first point. Then second point, all the components must be bilateral, meaning the current is the same amount of opposite polarities of the source. Means the bilateral means the current can be travel in any direction, means left to right, right to left. If let me take resistor over here, the resistor is 2 ohms, right? So here I am taking the one DC, one battery. Here I am taking one more battery. So this resistor is connected between two active sources. So this you can give the supply like this, or also you can give the supply like this. So that is the reason you can name it as a RLC is a bilateral elements. So linear bilateral means linear means there is a proportional between those terms. Bilateral means either you can transfer the either you can pass the current in any direction. So the same amount of current should be passes through the left to right, right to left. That is about the bilateral. What about the passive components? RLC, who are the drawing the who the what the elements which are going to be drawing the current or power from the source is called passive elements. So passive components may be their components such as resistors, inductor, and capacitor. Do not amplify or rectify. So don't use amplifier, rectifiers, and means diodes. Diodes are not comes under the um, even though that is passive, but those are not linear. That is the reason I included that do not amplify or rectify. And what about the active components? Active components may not be used. Active components include transistors, semiconductors, diode. Here that is not active sources. I said components means I included active components means transistors, semiconductor diodes, electron tubes. Such components are never bilateral and seldom linear. So these are not bilateral. I said clearly these are only unilateral devices, means they can active only one side, one way of current. Either if a reverse mode of current will comes to the across through that elements, that will be open circuited. When they will be closed, when the proper way of connection means when the forward bias of current is which are flowing through that particular elements, I can say diode, then that will be conduction mode. Otherwise that will be forward reverse direction mode, means that is a open circuit mode. So you should remember this conditions, means you should note down these conditions before we are discussing the problem. Please kindly go through this slide again. Right, let me move to the next slide. Procedure for applying superposition theorem. There are certain procedures. First, circuit containing only independent sources means like I showed here, like this. Circuit containing only independent sources. These are independent. Already you know dependent sources like this. They are showing in the rhombus mode. You can add in the rhombus in the independent sources in the dependent sources also, but that is not under your syllabus. That will comes on your graduation level. But as of your diploma level, this is enough for you guys. So here the first point is only independent sources. Consider only one source to be active at a time. This is very important point. First point, circuit containing only. So please guys note down these points. These points are very important before we are doing the problem. You should make a note of this all the points. Write it down, please. Second point, consider only one source means one active source at a time. Remove all other ideal voltage sources by short circuiting. This is very important. Ideal voltage sources by short circuiting, and all other ideal current sources by open circuiting. Right, means ideal voltage sources, how the ideal voltage sources will be shown to you. This is the ideal voltage source, this, and minus over here there are the resistance over here by short circuit. Same, right? Means what I'm trying to say, ideal voltage sources are replaced with their internal resistances. You can write that wording clearly. Remove all other ideal voltage sources which replaced by with their internal resistances. What is the internal resistance of ideal voltage source? 0. Then I am going to be short circuiting this. Same, my third wording, my ideal current sources are replaced by their internal resistance, that is infinity. Means this is ideal current source which is going to be replaced with the internal resistance infinity. Means how, when the internal resistance will be infinity, when this is open circuit only, that will be in infinity. So this is infinity, this is short circuiting SC, or I can name it as a 0 to infinity. This is 0, this is infinity. I will repeat it again. First point is consider only one active source at a time. Second point, all ideal voltage sources must replaced with their internal resistance, that is 0. My third point, all other ideal current sources are must replaced with their internal resistance, that is infinity. In other words, I can say ideal voltage sources are short circuited, ideal current sources are open circuit. So you can use this types of wording while you are writing the procedure of superposition theorem. This is very important. 3 rules. So you should note down this, and you should note down this diagrams also. Voltage source is replaced by short circuit or replaced with by internal resistance R0. Current source is replaced by, means ideal. This is ideal. Replaced by infinity. So this is about this slide. Let me move to the next slide. Right. If there are practical sources, replace them by combination of ideal source and the internal resistance as shown in figure, like this. After that, short circuiting the ideal voltage source and open circuit the ideal current source. Same thing what I explained here. You can implement that logic before before these 2 points. I discussed the different wording about that point. What I use the wording is ideal voltage source are replaced with the internal resistance R is equals to 0. Ideal current source are replaced with the internal resistance R is equals to infinite. Already you know this funda in our previous session. On the session, we already we derived the how the R is equals to 0 comes to the picture, how the R is equals to infinity, how it comes to the picture. We derived the derivation in our previous session. If you have any doubt, please go through the session, then come back to here. Right. So here, if the practical current source, if you given any practical voltage source like this, how you can name it as this practical voltage? In the practical voltage source, the resistance will be present, right? That is the reason I'm going to be name it as this is practical. This is practical voltage source PVS, and this is practical current source. How you can say this is practical current source? Because in this source, sorry, in this circuit, the resistance, sorry, the internal resistance is parallel with the current source. That is the reason I am naming it as this is practical current source, this is practical voltage source. In this, how you are using this technique while the converting of only, while the making of only one active source is going to be considered. For that, you should replace with this voltage source with the internal resistance 0. For this, you can replace with this current source with the internal resistance of infinity. These are the rules. Whatever we are discussing, all are rules, or you can name it as a procedure. So this is not the problem. Till now, we are discussing on the rules. We will discuss problem further. Don't worry. So you should remember these rules. Please kindly concentrate here. Right. Hope you clear about these rules, right? So first rule is you should consider only one active. Second rule is ideal voltage source replaced with the internal resistance. that is R is equals to ideal voltage source and ideal current sources are replaced with their internal resistance, that is R is equals to 0 and R is equal to infinity respectively. So same practical voltage source also same. In the practical voltage source there is a current source will be present, sorry, in the voltage source is present. Voltage source is nothing but a, you should taking k, you should assume as a, that is ideal voltage source, then ideal voltage source is replaced with this infinity 0, then practical voltage source is replaced with this infinity. So that is the reason you will get this types of combinations circuits. Right, let me move to the example number 1. In small example, this is how the conversion is going to be happen with this example. After this we will discuss few more examples. Before doing this example, let me write, after completion of this example 1 we will discuss about the superposition theorem in detail, don't worry. So in this I used only actual parameter of words v1, v2 and r1. I am not using any numerical parameters. Here find the current flowing through r, sorry, find the current flowing through r, find the current flowing through r. For that, if we asking, if we in the question if we ask by using superposition theorem, you should use superposition theorem only. Otherwise you can find the current easily by using the loop, by writing the loop equation. Already you know v1, v2, r, then you can find the current easily. But he is asking particularly solved by using superposition theorem, you should use superposition technique procedure only, right? First rule is you should consider only one active source. That is the reason I am going to be considering only one active source. What about the second source is going to be replaced with the internal resistance. What is the internal resistance of v2? 0. Means ideal voltage source internal resistance is 0. That is the reason I am making short circuiting of v2. So then I did short circuiting. After the making short circuiting, then I am going to be find the i1. I1 is nothing but a, the current is flowing like this, while I am considering this negative to positive. This is path. I1 is equals to v1 by short circuiting the voltage source v2. Finding, you should mention these types of wording because you are learner. Um, in the learner you should explain clear and crystal of every step. Here for the finding of I1 you should depend upon voltage and current, then then you will get I1. Next, say in step number 2 you should consider v2. In here you are considering v1 by making the v2 short circuiting. In step number 2 you should consider v2 by making short circuiting of v1. That's what happened here. Please observe here, v2 is over here, v1 is short circuited. For this you can find the current. For the direction of current you can take like this or like this, that is doesn't matter for you. But here you can find why I took this direction because he is asking current in this direction. That is the reason for the both voltage sources which is going to be activated in the step 1 and step 2, I consider the same direction, right? So then I consider the I2 in the same direction, but this direction is exactly opposite to the, that is the reason I am taking as a negative, minus v2 by r2, minus v2 by r. Then for this the two currents are entering to the r. One is I1 by making a factoring of v1, one another one is I2 by considering the v2 voltage source. This is I2, this is I1. So then then add both currents I1 plus I2 means v1 by r minus v2 by r. Then you will get current which is flowing through this resistor. This is about the, this is, try to observe here, you will get the answer in terms of v1 by r minus v2 by r. Then you will get a current which is flowing through this in this direction, right? You will get a. Now let me see one exercise problem. in this. So let me find this. Right. Already we observed these steps in our previous slide. So just I am taking the best slides for the superposition theorem. Don't confuse here. Just follow my instructions. Right. Let me solve one exercise problem. In this problem, here please observe here. Use the superposition theorem. Find the current through the R2 of figure 17. This is a figure. In this figure, kindly find through the current through the R2. He's not given any direction. Means upwards or downwards. He is not given. So then you can use any one of the directions as per your assumptions. So this is the direction I am assuming. So you want to know the current flowing through the R2 resistor. As you know, we have the multiple steps. I think 6 to 7 steps we have. For that, step 1. What is our step 1? Replace VS2 with the internal resistance, that is 0 ohms. After the making 0 ohms, here there is a resistance is there. But here for the ground is common, right? So for the making confusing, here the circuit is given like this, but this is common for this. So you can, for the clear understanding, let me give, let me add this marker. Let me add marker, wait. This is the direction is given. Next. So this is the common. This is the common. So don't confuse. Right now it's clear for the in the visual also. Now my first step. Replace VS2 with the internal resistance, that is short circuiting. Then for the finding of current through this R2, first you require the current drawing by this entire circuit, that is total current. You can assume that is total current IT of source S1. Whatever assumed IT of source S1. I'm mentioning IT of source S1. Then you will get total current, which is I mentioned here. Right. For the finding of IT of total S1, you require VS1 by total R equivalent of this resistors. So for how you are going to be find this R equivalent, for this finding of R equivalent, you should depends on the resistors construction, how the resistors are connected. Some of the resistors are connected in series, some of the resistors are connected in parallel. Here this R2 and R3 same resistance values are connected in parallel. So for the parallel resistors, if the same value, that means it's divided by 2. R2 divided by 2 or R3 divided by 2, both are same, or you can do 100 into 100 by 100 plus 100, same answer, you will get 50 ohms. So this is of this parallel of this R2 and R3, which is in series with this R1. Then the total resistance when we are activating the supply of 150 ohms. Then by using the 150 ohms and the supply voltage, then you will get total current which is supplied by source 1. ITS1 is equals to VS1. Already you know VS1 is 10 volts by total resistance 150 ohms. Then you will get 66.7 milliamps total current, means ITS1. But you need to find the current which is flowing through the R2 resistor, means 100 ohms. For that, you should depend upon the current division rule. Please write the current division rule. Current division rule is nothing but a total current into opposite resistance by total resistance. For this, the opposite resistance of R2 is R3. by total resistance. You should write the R2 and R3, which is wherever the current divided, only you should include those resistor is the summation of those resistors. Don't include R1 because from the R1 the current is not divided, current is flowing through the R1, means total current is which is drawing by R1 itself only. From after the R1 point, means after away from the R1 only that current is divided, right? So current divided to the R2 and R3. That is the reason you should include R2 and R3 in the denominator. Then by substituting this R1, R2 and R3 in this equation, then you will get current which is flowing through the R2 resistor only. Then you will get 33.33 amps of milliamps of current which is flowing through the R2 resistor. But this is only one procedure, means this is one case one. What about the case two? Right, I'm considering case two. Please let me draw this line. This is common for the making of your confusion. He given different grounds, means somebody may get confused and this is open circuit, so they will get struck. That is the reason they given these types of problems in your examination point of view. You should not confuse, means ground is all for them. So then you can make a contact of those all grounds is means complete one circuit, right? Hope you clear. But practically this is the case only. Your understanding purpose only, you are drawing a line between those grounds, right? So here in my case 2, I'm taking a VS2 is active, VS1 is a short circuit with the internal resistance. The internal resistance is 0 ohms. So from here I need to find the total current which is supplied by VS2. That means I mentioned the I2S2, same word please mention here. It's very hard to write by using mouse here. So I2S2, please write I2S2 over here, I2S2. So this is total current which is supplied by source 2. That means, so I2S2 is nothing but a VS2 by R2S2. R2S2 is nothing but a total, R equivalent means total resistance when S2 is active. For that, here the circuit is like this. R2 and R1 is parallel, which is series with the R3. Please mention carefully, but the answer is same, 150 is same, but don't concentrate on the answers. Please always concentrate the procedures. Please concentrate the procedures. Answer may be good, maybe vary by the changing of the values. Don't concentrate on the answers. Please ikkada R3 plus R1 by 2, then R3 is nothing but 100 ohms. R1 by 2 is nothing but both resistance are same, 100 and 100. Then it will become a 50 ohms. 100 plus 50 is 150 ohms. Then it will become a 150 ohms. So then you will get I2 total current supplied by source 2, VS2 by R2S2. VS2 is nothing but 5 volts. In this previous 10 volts is there, VS1. Here the 5 volts is there. Please mention that numerical values carefully, digits carefully. 5 volts by 150 ohm. Then you will get 33.3 milliamps total supplied by the VS2. Total current supplied by VS2. Now you should know, you should find the current which is flowing through the 100 ohms, which is R2 resistor. Not 100 ohms, R2 resistor, because there are 200 ohms. One is R1, one is R2, but you want to know the current which is flowing through the R2 only. For that, the current through R2 is due to VS2. I2 S2 is nothing but a total current into multiply with the opposite value of resistance, means R1 by total value of resistance R1 by R2. Wherever the current divided, you should consider those resistance in the numerator, in the denominator. So then 100 by 200 into multiply with the 33.33. Then after the doing mathematical things, then you will get 16.7 milliamps. Both the directions in downwards. When VS1 active, the current is in downwards. Please observe here. When VS2 is active, the current also in downwards. In the both cases, the current is in downwards. Then for the finding of total current in two cases, so you should adding of these two currents. One is for the activating of source 1, second one is when we are activating of source 2, then it will become a total 50 milliamps of current which is flowing through this R2 resistance when two sources are active. Please I will I will repeat it. When two sources are active, the total current 50 milliamps which is flowing through the R2 resistor. Then after the completion of this problem, you should note down you should draw the complete circuit like this. Complete circuit by mentioning 50 milliamps which is flowing through the 50 milliamps which is flowing through the R2 resistor. This is the way of doing superposition theorem problem. Please kindly make a note of every point. So hope you clear this session. In this session, we discussed the superposition theorem statement and we discussed the basic procedure of superposition theorem. And in our next section, we will discuss few more problems on the superposition theorem. Thank you. Thank you. Thanks for your time. Bye bye. Have a good day. So some other method also, you can find the total current which is flowing through the resistor R. This is the method you can obtain by using this method also. You can finding the voltage difference is nothing but a potential difference, that is VR, means voltage across the resistor means V1 minus V2. This is equation 1. As you know, VR is nothing but a I is equals to VR by R. Current flowing through this element is nothing but a V by R. Voltage by resistor. Voltage is nothing but a voltage across the resistor, V1 minus V2 by R. Then I is nothing but a V1 by R minus V2 by R. This is one of the method you can find in the flowing of current. This is direct method, but this is a step 1 and step 2 is based on the superposition theorem methods. So there is one more PPT you can observe here. In this PPT, here I want to add the few steps. Here I want to add few steps. So in the steps, this is the way of solving the one problem. So this is a problem is given. Please observe here. I encountered by using circles. So this is problem is given like this. So in this problem, just observe this way of presentation. So first, this is a source VS1. Source VS1. Let me add marker. Source VS1. This is source VS2. So the question is find I2. Here I given only integers. I never included the numerical values. I used only voltage V, R1 and R2, I2 like that. Then I will take one numerical problem after the completion of this example. So here for the problem, he's asking only current flowing through this R2 resistors, means in this direction. The direction is downwards. Please observe this direction. The direction is downwards. So this is the problem is given. The step 1. What is our step 1? This is step 1. For the step 1, you need to be activate only one voltage source, then another voltage source is replaced with this internal resistance. If this is the ideal voltage source, what is the internal resistance? How, when your name it is, this is a non-ideal voltage source, because when VS1, if you mention VS2 comma the resistance of 0.2 ohms, if you mention like that, then that means that is practical voltage source. But here he given only voltage source which is series with the resistance, means this is the ideal voltage source, means I am going to be replaced with this ideal voltage source with this ideal voltage source with the short circuiting like this. So this is short circuiting path. So now let me apply what I need to apply. It's not required KCL, it's not required KVL, just simple resistance principles, that is series and parallel principles, as you know. Here, wait a moment, Here, so this is step one. Step one, you can replace with this short circuiting with the internal resistance of Vs2, that is 0 ohms, and you are going to be activating a Vs1. So for this, in step two, you can do simple resistive techniques, that is series and parallel. Here, this is R2 and R3 are both are parallel. Even that is making short circuiting. This R2 and R3 both are parallel. That is the reason I included this R2 and R3 parallel, which are in series with the R1. Then you will get total R equivalent, total resistance RT. I'm mentioning total resistance RT when I using the supply of 1. So I include the suffix total resistance when I use supply 1. Then I will get RTS1. So for the finding of RTS1, you should know total current by using this resistance. Total current is nothing but a total voltage by total resistance, that is Vs1 by RTS1. Then you will get total voltage. That is step 2. What is step 3? In step 3, find I2. Now you got the total current, that is this current. For the finding of I2, you should depend upon the CDR, current divider rule, current division rule, that is current divider. Current divider rule is a total current into opposite resistance by total resistance, opposite resistance of this R3 and total resistance R2 plus R3. Don't include this R1, right? You should know the basic rule of current division rule. Please, if you are not understanding the current division rule over here, please kindly go through my previous videos, then start gather knowledge from there, then start this session, right? So here for the finding of I2, Vs1, due to Vs1, then you are going to be finding total current. Sorry, by using total current, you are finding the current flowing through the R2 resistor. Up to here, this is complete one process. This is case one. This is one procedure. Next, second procedure, you are going to be making short circuiting of Vs1. You're making short circuiting of Vs1, and you're going to be finding the voltage. Sorry, you're going to be finding the current, total current by using Vs2, right? You're going to be finding. So in case 2, you are using only Vs2 by making the short circuit of Vs1. Here, you please observe here. Replace Vs1 with the 0 resistance, that is the internal resistance of Vs1. Then you are going to be find the total current by using this total R equivalent. For this, R1 and R2 are parallel. Please observe here, R1 and R2 is parallel for this circuit. You need to be find by making this R equivalent of this R1, R2 and R3. How you are making R equivalent? This is R1 and R2 both are parallel, which is in series with the R3. So that is the reason I mentioned R total by with the reference of supplying 2 second voltage source. So here for the finding of total current by supplied by second source is equals to total voltage of second source by total resistance with the reference of second source. Then you will get total current which is supplied by the second source when you are short circuiting of primary source by Vs1. Then you will get Is2. Then you will get total current. Then for the finding of a particular current which is going to in this directions, but in the question itself he given the same direction, but your assumption also in the same direction. So hence you're going to be find the current flowing through this R2 when Vs2 is active. When Vs2 is active, then I2 is equals to opposite resistance means R1 into total value of resistance R1 plus R2. Don't add this R3 because the current is divided to R1 R2. Current is not divided to R3. This is R3 supplied through the current flow through the R3 means total current which is flowing through the R3. That is reason you should not include the R3 while you are finding the resistance, while you are finding the current flowing through the resistance of 2. Right here, R1 by R1 plus R2 into I2S2. Then you will get current flowing through the R2 resistor. Then by making activing of VS1, you know the current IA2S1, that is one current, and for the making active of VS2, you know the current of I2S2. Then you got the two currents. One is I2S1, second one is I2S2. Then the total current I2 is equals to I2S1 plus I2S2. So this is the procedure of doing. Let me remove my all markers. So this is the procedure of doing superposition. Please kindly note down all these pictures. Then you can be able to understand what superposition theorem actually intention. You can find this current flowing through this particular resistors by using mesh analysis, nodal analysis, Kirchhoff current law, Kirchhoff voltage law, loop equation based on the loop currents, loop equation based on the branch currents. You can use many methods. But here, if you are asking superposition theorem, means you should follow these types of procedure. So for here, 1, 2, 3, 4, 5, 6, 7. Total 7 steps is mandatory. So this is final circuit. For every circuit, for the every problem of any circuit, there is a final circuit is there. For that, you need to draw the circuit at the end of your completion of your problem, right? Let me see.